Hi, my name is Basir. This video is part of a playlist where I cover chapter 10 mensuration for Telangana state syllabus. Now, in mensuration, we mostly find out the surface area, the curved surface area, and the total surface area, and also the volume. Now, we will be dealing with these figures here: cuboid, cube, right prism, regular circular cylinder, right pyramid, right circular cone, sphere, and hemisphere. Now, let's say you are sitting in a room. A room would probably have four walls, right? Area of those four walls is nothing but the lateral surface area. Area of the four walls is nothing but the lateral surface area. Now, if you look at the cylinder, the cylinder does not have any flat surfaces. That's the reason we call the lateral surface area as the curved surface area, because it just have a curved figure in place of flat surfaces. So so we use the term curved surface area for a cylinder. So I was giving you an example of the room that you are sitting in. And the room has four walls, and the area of those four walls is known as the lateral surface area. If you include the top ceiling or the top roof and the bottom floor, then it becomes the total surface area. Let's take the example of a cube. A cube probably has six faces, right? Now, the four sides, area of those four sides is 4a square, because area of each side is a square. Now, each side in a cube is in the form of a square, and area of a square is side into side. So the side is a here, a into a is a square. So area of each side is a square. Now it has four sides, so the area would be 4a square. So that's the lateral surface area of a cube. And to find out the total surface area, you need to include the top and the bottom. Again, the top is a square, the bottom is a square. So 4a square plus a square plus a square, it makes 6a square. One little hint that would help you is that you have to understand the the sum of the powers in a volume will always be 3. Let's say I look at the volume of a cuboid. The volume of a cuboid is LBH, right? The power of L is here is 1, the power of B here is 1, the power of H is 1. 1 plus 1 plus 1 is 3. So the if you add the powers of the variables in a volume, it will always be 3. If you look here in for cube also, volume of cube is a cube, so the power of the variables here is 3. If you look here in our fourth example, which is a regular circular cylinder, you see that the volume of a cylinder is pi r square h. So the power of r is 2 here, the power of h is 1, 2 plus 1 is again 3. So this one little hint will help you. And area, the power of variables will add up to 2, right? In a cuboid, you have three dimensions: length, breadth, and height. So you have three variables here: L, B, H. In a cube, you have just one variable, A. In a cylinder, you have only one variable, two variables, R and H. Okay, so now that you understand what is the lateral surface area is nothing but the area of four walls, and the total surface area is, you get total surface area when you add the top floor and top roof and the bottom floor. Now that you know this thing, let's go ahead and try to derive the formulae for these figures. I'll first start with a cube. So we'll be finding the lateral surface area, the total surface area, and the volume for these figures. I'll start with cube. Cube probably would be like this, right? All the sides in a cube are equal. All the sides in a cube are equal. Now what would be the lateral surface area of a cube? Lateral surface area of cube is lateral surface area is nothing but area of four walls, right? The and each side of a cube is, let's say I represent the side of a cube with the letter A. Now each side here is A. Lateral surface area would be 4a square, because area of each wall as such would be a square. So area of four walls is 4a square. Total surface area is when you add the top and the bottom. So if I add the top a square and the bottom a square, it becomes 6a square. Volume of a cube, volume of a cube is a cube. If you uh, if you see the volume of a cuboid, volume of a cuboid is L into P into H, LBH. Volume of a cuboid is LBH. Here length, breadth and height in a cube are all equal. So this is A, this is A and this is A. So A into A into A is A cube. You don't really have to by heart the formulae for a cube. It's all easy, right? Now let's move to cuboid. Cuboid, here I'll just write down cuboid. Okay, I'll just take a new space here. Cuboid. So this is my cuboid here. Let's say this is my length here. This side is my length and this is my breadth and this is the height. Now if I just consider four walls, the lateral surface area of a cuboid is 2h into L plus B. Lateral surface area of a cuboid is 2h into L plus B. Let's say I want to show you this thing here. If I cannot really draw a three-dimensional figure in this using this, let's say I want to shade the four walls here. Left side is one wall here, this right side is one wall. Now if you look carefully, this side is B and this side here is H. So the area would be B into H for this side that I shaded here. B into H is BH. BH is the area of this wall here. Now this wall also would be BH, same. Now if I take this wall here in the front, you would see that this is the length here, L, and this is the height here, H. This side is the length, this side is the height. So L into H is LH. So you get the area here as area of this wall or this side as LH. And if in the back also the same case would be there, it would again add up to LH. BH plus BH is 2BH and LH plus LH is 2LH. And if I take 2 and H common from here, I would obviously get something like this. Here B is remaining and here L is remaining, right? So the lateral surface area of cuboid will become 2H into L plus B. If you don't understand how we derive the formula for finding lateral surface area of a cuboid, do not really worry. You can just pretty much remember this formula. It's quite easy. Lateral surface area of cuboid is 2H into L plus B. In the same way, I can pretty much derive the formula for finding total surface area of a cuboid. But I believe instead of deriving the formula, I would just show you a trick. The trick is quite simple here. Just draw a circle, put the letter L here, the letter B here, the letter H here. The total surface area of a cuboid is nothing but 2 into LB plus BH plus HL or LH. So 2 into LB, this here, LB plus BH plus LH. That's your total surface area of a cuboid. And the volume of a cuboid, volume of a cuboid is L into B into H. In general, the volume is area of the base into height. In general, the volume is derived using this thing, area of the base into height. If you look at the base of a cuboid, the base is nothing but it is a rectangle. It is in the shape of a rectangle, and we know that the area of a rectangle is L into B, right? Volume is usually volume is area of the base into height, right? The base is in the form of a rectangle here in the if we consider a cuboid, the base is in the shape of a rectangle. Area of a rectangle is L into B, LB into height. We represent it as h, so it becomes LBH. So that's how you get the volume of a cuboid. Volume of a cuboid is LBH. Now let me move on to another figure here. I'll take a cylinder. This cylinder, it has a curved surface. So this curved surface, the entire curved surface that you see here, that entire curved surface form your curved surface area. I've just written the abbreviation here. C.S.A stands for curved surface area. Curved surface area of a cylinder is nothing but 2 pi r h. Curved surface area of a cylinder is 2 pi r h. In general, curved surface area of few shapes, we take them as perimeter of the base into height. Now the perimeter that you see here, the base is in the shape of a circle, and the perimeter of the circle, you know that it is 2 pi r into the height here is represented by h. So h is your height. 2 pi r into h becomes 2 pi r h. So that's how you get the curved surface area of a cylinder. Curved surface area of a cylinder is 2 pi r h. Now if you add the top flat surface, which is a circle, and then the bottom flat surface, which is again a circle, then you get the total surface area of a cylinder. Let's see what is the total surface area of a cylinder. Total surface area is curved surface area plus the top circle and the bottom circle. So I'm just writing here top circle and the bottom circle. What's the curved surface area of a cylinder? We derived it as 2 pi r h. Now area of top circle is, again, area of a circle is pi r square. Area of this bottom circle would also be pi r square. So pi r square plus pi r square is 2 pi r square. If I take 2 pi r common, I get here h plus r. 2 pi r into h plus r. 2 pi r into h plus r is nothing but the total surface area of a cylinder. So total surface area of a cylinder is 2 pi r into r plus h. Volume of a cylinder. Let's find out volume of a cylinder. I told you that volume is usually area of the base into height, right? The base is in the form of a circle, so area of that circle is pi r square into height, we represent it as h. So the area of the circle, the volume of cylinder here is pi r square h. So finding the lateral surface area and the total surface area and the volume is not that difficult. You don't really have to mug up the formulae. You can pretty much derive them on your own. This is just a very simple understanding. Lateral surface area would be area of 4 walls, so it's 4a square, and the total surface area would include the top roof and the bottom floor, so it becomes another 2 sides gets added here, so it becomes 6a square. 4 plus 2 is 6. Volume of a cube is a cube. So we have gone through 3 figures here. Let me just choose a new worksheet to go through the rest of the figures. Let us consider the cone now. Cone. Cone probably would be like this, right? You must have seen a ice cream cone, right? So, or a joker's cap is nothing but in the shape of a cone. Now, cone, this surface that you see here, this forms our curved surface area, and if you include the bottom circle, that adds up to total surface area. So, curved surface area of a cone, curved surface area of a cone is pi r l. First, let us understand how many dimensions or how many variables are here in a cone. I'll draw a cone for you once again. So that's our cone here. We understand that the base of a cone is in the shape of a circle, right? And a circle would obviously have a radius, right? Let us say the radius of this base is r. The radius of this base is r. The radius of the base is r, and the height of the cone is h. This line here, that is known as the slant height, and the slant height is represented by L. This h that you see here, that is our perpendicular height represented by the letter h, and this line that you see here, that is the slant line represented by the letter L. Now if you carefully just look at this triangle here, H, R and L, this forms a right angle triangle, right? H, the side H, R and L, these three things form a right angle triangle, and in a right angle triangle we can apply Pythagoras theorem, right? Pythagoras theorem says that the square of the hypotenuse, this slant line is known as the hypotenuse. The square of the hypotenuse is sum of the squares of the other two sides. So the value of L square here is R square plus H square. The relationship between L, R and H is L square is equal to R square plus H square. And the curved surface area of cone is pi r L. I can derive this formula, but this is one of those odd cases where remembering the formula is quite easy than deriving it. So I won't be doing it in this video. Probably I would include this in one of my other videos in a separate video. So curved surface area of a cone is pi r L. The total surface area of a cone. Total surface area of a cone is always curved surface area plus you have the bottom here, the circle. Curved surface area of cone, we see that it is pi r L plus the bottom circle that you see here, area of that bottom circle would be pi r square. Now if we take pi r common, we get here pi r into L plus R. So total surface area of a cone is pi r into L plus R, and the curved surface area of cone is pi r L. Let us see the volume of a cone. Volume of a cone. Volume of a cone is 1/3 the volume of a cylinder, and we have already derived the volume of a cylinder, right? Volume of a cylinder is pi r square h. So 1/3 of pi r square h, 1/3 pi r square h is the volume of a cone. Let me move to another figure here. Sphere. Let me take a sphere. A football or a globe is in the form of a sphere, right? Now in a sphere, we don't really have any flat surfaces. So that's the reason the curved surface area of a sphere and the total surface area of a sphere are equal, are just the same. So curved surface area of a sphere is equal to the total surface area of the sphere. So you don't have a separate formula for finding total surface area of a sphere because it doesn't really have any flat surfaces. If you take an example of a cone also, it has one flat surface here in the bottom, which is in the form of a circle. But if you look here in a sphere, you don't really have any flat surfaces. So that's the reason the curved surface area of a sphere and the total surface area of a sphere are one and the same. Now, curved surface area of a sphere is 4 pi r square. Curved surface area of a sphere is 4 pi r square. Remembering this is quite easy. You can remember it this way. Curved surface area of a cylinder is 4 times the area of a circle. 4 times area of a circle. Area of a circle is pi r square. 4 into pi r square is 4 pi r square. Now the total surface area of sphere again would be same 4 pi r square because it does not really have any flat surfaces. Now volume of a sphere. Volume of a sphere is 4 by 3 pi r cube. This again, is again one of those cases where deriving the formula is a bit lengthy than just remembering it. So this time you just got to remember this. Volume of a sphere is 4 by 3 pi r cube. Now let us consider a hemisphere. Hemi means half, right? Hemi means half. So let us now consider a hemisphere. Hemisphere, I'm just cutting this sphere into two halves. Then the other half would look something like this. Something like this. Something like this. Curved surface area of a hemisphere would be half of this. Half of the curved surface area for a sphere. Now curved surface area of a sphere is 4 pi r square. Half of this would be 2 pi r square, right? So the curved surface area of hemisphere, is equal to 2 pi r square. Curved surface area of hemisphere is 2 pi r square. You don't really have to remember it separately. You just need to remember the curved surface area of a sphere and just take half of it. Instead of taking 4 pi r square, take 2 pi r square. That would be curved surface area of a hemisphere. Now total surface area of a hemisphere is 2 pi r square plus pi r square, because if you look at a hemisphere, it has one flat surface in the shape of a circle, and the area of the circle is pi r square, obviously, right? So the curved surface area of hemisphere, we have it as 2 pi r square, plus we take this flat surface area of this surface, which is pi r square. 2 pi r square plus pi r square is nothing but 3 pi r square. 3 pi r square is the total surface area of a hemisphere. And the volume again is half of this, half of the volume of a sphere. So instead of taking 4 by 3 pi r cube, the volume of a hemisphere would be 2 by 3 pi r cube, because half of 4 by 3 pi r cube is obviously 2 by 3 pi r cube, right? 2 is a 4. 2 by 3 pi r cube is nothing but the volume of a hemisphere. So we have gone through most of the shapes here. I hope by now you must be knowing how to find out how to quickly remember the formulae for all of these shapes. You just remember two quick tips here. One, if you are finding the area, let's say here I found out the curved surface area of a cone, which is pi rl. If you are finding the area, the sum of the variables would be 2. So the power of r here is 1, the power of l here is 1. 1 plus 1 is nothing but 2. So sum of the variables in the formula for finding area would always be 2. And if you are working out a cone, the sum of the variables will always be 3. Like in this case, if I take volume of a cone, the power of r is 2, the power of h is 1, 2 plus 1 is 3. At times you may just get confused. Is the volume of cone 1 by 3 pi r square, or is it 1 by 3 pi r square h? See, this cannot be the volume because the power of the variable is only 2 here. So obviously you will understand that this is the volume of a cone, and volume of a cone again is 1/3 the volume of a cylinder. Okay, I hope you would remember this. um, I'll stop this video here. I'll probably start working out exercise 10.1 in the next video. I'll see you all in the next video. Until then, goodbye.